Now, this illustration is still dealing with a grounded conductor. In accordance with 250.30A3C is in car. Now, we've been reviewing where a grounded conductor may be a neutral too. It could be a bonding means. It could be a path for fault current. It could also be a neutral. Serve three functions for us. But here we're looking at a corner grounded system when it's a separately derived system. And we're just showing the secondary side of this transformer. We're not showing the primary, where the primary is supplied from service equipment or from a sub panel maybe. But notice some important information is given. The transformer disconnecting means we'd see 450.14. And we don't want to forget now that transformers require disconnect starting, I believe, with the 2017 edition of the NEC. So we would look at that. Now, the next thing I would like to review with you is the notes. Note 1, a call current is 58% of the phase-to-phase current. So if we add 200 amps on L1, L2, and L3, respectively, then notice 58% of 200, the winding call current would be 116 amps. But in note 2, the phase-to-phase voltage is also going to be your call voltage. So if you had 480 volt phase-to-phase, you're going to have 480 volt in the windings of this delta connected system. Note 3 says the grounded conductor shall have an ampacity not less than the ungrounded conductors as required in 250.30A3C. Now, if we look at that very carefully, what it's saying that you can't reduce that grounded conductor like you could if it was a neutral, say in a dwelling unit. And back in the Annex D, we used to have a note there that said usually the grounded neutral conductor was usually about 2 sizes smaller, the grounded conductor. Now, a lot of folks just took that for granted, and they would take the corner grounded delta and just drop that neutral 2 sizes. Again, misinformed, using the code in a manner that violated the code. So we want to make sure that, as you see, we are grounding in the first disconnecting means. We have rigid non-metallic conduit. No parallel paths could possibly be present there. And we do not have any kind of grounding connection to the enclosure from the windings in the transformer secondary. So we would have say a 2-pole main there, as you see, disconnecting means and main. And notice that 240.85 says it has to be marked single phase, 3-phase. That means you shouldn't be using just a regular 2-pole breaker there that a lot of our folks use. And if we reviewed NFPA 70B, and we reviewed the chapter 17, then it refers you to 240.85 when you change out a breaker. And also, you have to see how the system is grounded if it's not a delta. Say it's a Y system. Then you have to make sure that you apply the straight mark breaker or the slash mark breaker, which we reviewed in detail in Volume 1 to Stallcup's Electrical Design book in Chapter 9. And we said a slashed mark breaker references voltage to ground, so to speak, and phase-to-phase voltage. Where a straight mark breaker is 600, 480, 240, straight mark. And it can be used on any system. But the slash mark breaker that referenced the voltage to ground, like 120, 240, 120, 208, 277, 480, can only be used on a solidly connected to ground system, as you see in the panel board. that conductor is run unbroken, in this case, and connected to the electrode system, which is usually, like we said, the building steel. So this illustration just basically says review 250.30A3C as well as 250.20 and 250.26 that we've already reviewed in this chapter 16, along with 110.21 and 110.24. And you get a very good feel for what this is, the code's requiring. And notice when you look at 250.26, item number 4, it addresses this corner grounded system. But do you see the sections you need to review to get a good handle on the labeling that you put on the panel? If any additional requirements are required there, such as for an ungrounded system, or you have additional requirements for a corner grounded system on your label to let electricians know what type of system that they're working on, or they're performing maintenance, repair, whatever. So this figure 16-41 deals with a grounded conductor when it's a corner grounded system and it's actually an ungrounded phase that is connected to ground, as you see in this illustration 16-41.